We want to look at modeling composite goods. Till now, we mainly talked about a two-good world where we had one good x1, which you were plotting on the x-axis, and another good x2, which you were plotting on the y-axis. But in reality, we face multiple goods when making choices, and we're not living just in a two-good world. Now, we could illustrate such choice sets in more complicated graphs. So far, we're looking at 2D graphs, right? On the horizontal axis, we had x1, on the vertical axis, we had x2. In a three-good world, like where we had, say, x1, x2, x3, we would need three axes, right? Where we on one axis we'd plot x1, another axis like we would plot x2, and another axis we would plot x3. Right, but this would become quite difficult, right? Working with three-dimensional graphs would become quite would become quite difficult. Because see over here, if we have a three good worlds on one axis, we could plot x1, another axis we could plot x2, another axis we could plot x3, but that would become very difficult, right? So what we want to do is we want to look at how we can transform multiple goods into a two-good world to analyze more general choices graphically. So instead of like using for a three-good world, three-dimensional graphs, what we'll do is we'll transform our multiple goods into a two-good world, right? And how are we going to do that? We're going to do that by introducing the concept of a composite good. We put the good when rusted in on the horizontal axis, and we're going to combine all of the goods as a composite good denominated in dollars, which we'll put on vertical axis. So we're still working in a 2D graph. On the horizontal axis, we put the good we're interested in, and on the vertical axis, we combine all of the goods into a composite good. The composite good will represent all of the goods except for the good when rusted in, which we'll put on the horizontal axis, and each unit of the composite good is priced at $1. So we basically define, and the way we define this composite good is dollars spent on goods other than X1, each unit costing $1. So in this way, we can transform our multiple goods into a two-good world. You put the good you're interested in on the horizontal axis and combine all of the goods into a composite good and put them on your vertical axis. Right, moving on. Okay, so sorry. So now let's look at the equation of budget line in this case where let's say X2 is a composite good. So we know, and where we know the price of a composite good, like we said, is $1, right? The composite goods represent all of the goods, and each unit is priced at $1, so P2 is 1. We know when we write the equation of the budget line, we're looking at all those combinations of x1 and x2 that cost exactly equal to income. So it's P1 x1 plus P2 x2 is equal to I. In this case, where x2 is a composite good, we can write P2 as 1 because each unit of the composite good is priced at $1. From here, now we can make x2 the subject, the reason being that we're plotting x2 on the vertical axis and x1 on the horizontal axis. So when we write it in this form, from here we can easily identify the vertical intercept and slope as it's in the y is equal to mx plus c form. From here we can see the vertical intercept is I. Initially when we're looking at x2 not as a composite good, then it was I by p2. But because x2 is a composite good and the price of each unit of composite good is $1, the vertical intercept simply becomes I rather than I by p2. The slope over here is simply minus P1, right? So it's simply minus the price of the good we're concerned with rather than the ratio prices it typically is. So when you're writing the equation of budget line for the composite good, right? So we know, okay, the idea behind the composite good is that each unit of the composite good is priced at $1. So P2 will become 1, and we can simplify the equation of our budget line by setting P2 is equal to 1. So we talked about the economic interpretation of the slope of the budget line as well. In this case, we know slope is minus P1. So in this case, and we know the interpretation of the slope was its opportunity cost of one more unit of the good on horizontal axis in terms of the good on vertical axis. Here it's the opportunity cost of one more unit of x1 in terms of units of composite good because the composite good is on the vertical axis. But in order to have one more unit of x1, you have to give up P1 units of composite good or $P1 worth of other goods consumption, because we know, just keep in mind, whenever we're modeling composite goods, we're combining all of the goods into a composite good and the price of each unit of composite good is P1. So you're giving up P1 units of composite good, or you can also say $P1 because each unit costs $1. So slope still has the same economic interpretation. It's the opportunity cost of one unit of x1. Now it's in terms of units of composite good. So in this way, we can model multiple goods by just transforming them into a two-good world, where you put the good you're interested in on the horizontal axis and combine all of the goods into a composite good. And here, keep in mind, the price of each unit of a composite good is $1, so it simplifies the equation of our budget line.